So far we've been looking at how do I find extrema, and using the first derivative and what we call the first derivative test to find intervals, determine where my function is increasing or decreasing, and then from there make the jump to say if it goes from increasing to decreasing, I must have a relative maximum, and if it goes from decreasing to increasing, I must have a relative minimum, or a local maximum or local minimum as they're also called. We've also looked at concavity and said that if my second derivative is greater than 0, then I must be concave up. And if my second and therefore my tangent line is below my function, and if my second derivative is less than 0, I must be concave down, and therefore my tangent line is above my function. If we extend and kind of put those concepts together, we get what we call the second derivative test. The second derivative test is going to allow us to say if I know the value of a critical point when plugged into my second derivative, I can determine if there's a relative minimum or a relative maximum there. I must be aware, however, that sometimes my second derivative test fails, and I have to go back and use the first derivative test. Basically, though, what the second derivative test tells me is that if I can use my first derivative to find my critical points are going to tell me one of three things. They're going to tell me that I either have a maximum or a relative maximum, a relative minimum, or I have some kind of flat place occurring at a turn. So if I take my relative minimum or relative maximum and I plug it into my second derivative test, notice that if my second derivative tells me I'm concave down, therefore my second derivative is negative, then I must have a maximum. If my second derivative tells me I'm concave up, then notice I must have a minimum, which is what it says here. So again, if my second derivative, when I plug my critical point in, I know my critical point is not going to be any of these other values on the curve. I know my critical point is going to either be a maximum or a minimum. If I can then determine that I'm concave up, I know that I have to be at the bottom of that concave up curve. I have to be at a minimum. Similarly, if I already know I have a critical value, I'm not anywhere on my curve except for either the top or the bottom. Again, if I'm concave up, I can assume that I am at, if I'm concave down, I can assume that I'm at a maximum point. However, again, if it's 0, then the test fails and I'm going to use the first derivative test. So let's look at two examples on how the second derivative test works. So first thing I'm going to do is I'm going to go ahead and I'm going to find my first derivative so I can find my critical points. And then finding my critical points, I set my first derivative equal to 0. I don't have to worry about it being undefined since it's a polynomial. So I see that x is either 0 or x is 3. Those are my two critical points. I'm going to come back to those, but before I do, I'm going to find my second derivative. Because it's my second derivative, I want to plug my critical points in to help use concavity to determine if they're minimums or maximums. So my second derivative. So now I will plug each of my critical points into my second derivative. So I'm going to take the second derivative of 0, and I get 0, which is unfortunate because that doesn't tell me anything. Before I worry about that, I'm going to plug 3 in. And I see when I plug 3 in, I get 12 times 9 minus 24 times 3, which I know is going to be positive. Since my second derivative is positive, I know I'm concave up, and my tangent line therefore lies below my function, which implies to me that f of 3, so my original function at 3, must have a minimum. Again, I know because 3 is a critical point that it's not any of these other random points on my curve, but it has to be my bottommost point here. So I can go ahead and take the jump to say I have a relative minimum at the point 3, comma, I'm going to go ahead and use my calculator. I put 3 back into my original function because it's always about the point on my original function, and I get negative 27. But I have to go back. Remember, I had no idea what was going on at 0. So I'm going to go back to my first derivative test and say, okay, I'm going to use my critical numbers to set up my intervals. So setting up my intervals, I will go from negative infinity up to 0, from 0 up to 3, and from 3 up to infinity. Well, notice, and then I can pick my test points. I don't need to pick one in here because I already know what's going on at 3. I just need to figure out what's going on here at 0. Therefore, do I go from increasing to decreasing? From decreasing to increasing? Or do I remain increasing, increasing, or decreasing, decreasing? So I'm going to go ahead and pick a test point, say -1. I'm going to pick a test point, say 1. Remember, I plug my, because this is my first derivative test, so I plug my test point into my first derivative. So when I plug -1 into my first derivative, I see I'm going to get a positive times a negative, so a negative. And I notice that when I plug 1 into my first derivative, I am also going to, and I'm looking at this form here, it's easier for me to do it in my head when I use my factored form. I also notice I'm going to get a positive times a negative, so that's also going to be negative. So since it's decreasing the entire time, I realize there is no minimum or maximum there, so I'm going to stick with my original answer here that I was able to get from f double prime of 3 as my full answer. Looking at one more example with this second derivative test, I'm going to do the same thing with my new function here. So the first thing I'm going to do is I'm going to find my first derivative so I can find my critical points. And I get negative 15x to the 4th plus 15x squared. So I'm going to go ahead and set my first derivative equal to 0. I notice there won't be any critical points. I'm going to factor out a negative 15x squared. I don't like my first term to be negative. And I'll get x squared minus 1. So I see either x is 0 or x is either positive 1 or negative 1. So now find my second derivative so I can plug my critical points into my second derivative. And I get negative 60x cubed plus 30x. So f double prime of -1, I realize is going to give me 60 minus 30, so I realize that's going to be positive. Therefore, I can say that I have a, let's see, so if I'm positive, I'm concave up. So therefore, I must have a relative minimum. And if I plug in 0, I get 0, which again is meaningless. I'll come back to that. If I plug in 1, I notice I get negative 60 plus 30, which is going to be negative, which means I'm concave down. So my tangent line is above my function, which means I'm going to have a relative maximum there. So I can go ahead and already say I have a relative minimum at the point -1, comma, I plug -1 back into my original function and I get -2. I just used a calculator for that. And I can also say I have a relative maximum at 1, comma, again I plug back into my original function. Okay, but I also have to ask myself what is going on when x is 0. So I will go back to my first derivative test and set up my intervals. So I'll go from negative infinity up to -1, from -1 up to 0, from 0 up to 1, and from 1 up to infinity. And I'll pick test points. Again, notice the only one I care about is this one here, this middle one. I want to know what's happening at 0, so I don't have to worry about these two intervals. So let's say that I pick -1/2 here and +1/2 here. I will plug my test points because I'm back to my first derivative test into my first derivative. So when I plug -1/2 into my first derivative being right here, I notice that I get a positive. And when I plug it into +1/2 into my first derivative, I notice I also get a positive. So again, nothing is happening at 0, so I can go ahead and conclude that my only relative extrema are occurring at -1, -2, which is a minimum, and 1, 2, which is a maximum. So again, second derivative test is an alternative to using the first derivative test. However, keep in mind that you may have one or more points where you do have to fall back to your first derivative test when using that second derivative test.